Electric to be there this night, real like the universal light. All I knew that should be true is reality, and you turn to me. Electric to be there and see the universe reflecting to me. All I am would not be without your electricity. Turn to me.
I wanted to play something different today. I hope you enjoyed as much as I did. And if you managed to get what it was, eternal bragging rights and my undying respect are yours. Hello, everybody, and welcome to March Storm Community Call, broadcasting live to all the corners of the interweb. And that includes streaming on X also, or Twitter, as I like to call it. So, hello there, and you are very welcome to join the conversation in Discord. Thank you for coming. My name's Antonio, and I am very glad to be your host today, wherever you are within this pale blue dot. Well, what can you expect of the call today? Here's the agenda. We will start with core development feature updates featuring Nikki Papadotou. We'll have in focus BJS giving another boost and a node simplification. Community talk, OCI registry implementation on Swarm with Ata and Andrew from Dboot slash uncloud. And the community talk will go through Swarm-based data provenance framework. Finally, to conclude, we'll have a community AMA and open space for debate. And as an additional comment, Swarm Foundation team will be present at several conferences, starting at Lisbon and then moving to Prague in May. We'll see you there? Maybe. All right, if you're there, just give it a ring to some members and we can grab a coffee or a beer or something more daring. So let's start with the core development update. And for that, I would like to invite Nikki to stage because there are many things to talk, starting with the update 2.50. Hello, Nikki.
Hello. Hi, Antonio. Hi, everyone. Welcome to this month's community call. It's great to have you all here, whether you are deeply involved or just curious. Thanks for showing up and helping push the project forward. So let's dive into the latest updates. First of all, we have officially released B2.5 on March the 11th. This release focused on major improvements across performance, stability, and resource usage. Some of the highlights included better garbage collection, smarter postage stamp handling, and overall faster and more reliable data retrieval and uploads. You can check out the full release notes on our blog, and so far the results are looking very promising. Around 70% of the nodes have already upgraded, and the network appears to be stable and performing well. As a follow-up, we will be running the same performance tests we ran before the release, so we can make a proper before and after comparison and officially validate the improvements. We will share the updates of these results once they are in. As mentioned last time, we are working on a solution to better understand node and network behavior. This will now be implemented through StormScan, and it's already in progress. The idea is to measure things like upload, download speeds, and latency across different regions, giving us clearer insight into how the network performs in the real world. We are currently working on the implementation, and we will share all the details with the community as soon as it's ready. We have also made progress on improving the node spin-up process, making it easier and faster for people to get a node up and running. Aaron will share more about the objectives and milestones of this project, but for the moment being, our update is that the team is actively working on the tasks belonging to this epic Going to the next item, the research team is doing great work on the multi-chain support. The MVP is ready, all the functionalities are there, and now they're fixing the last bugs, making sure that we offer a seamless experience. Later on today, Dan will be on the stage with a demo of the tool, and hopefully this will give you a nice insight. We're very happy with the efforts and good progress there. And very soon we will be in a position to share the tool with all of you. So what's next? Looking ahead, the big next focus is network stability. The Epic is currently in the hands of the research team, and once the specs are ready, we'll jump straight into implementation. This will likely be a major step forward in strengthening the reliability and robustness of the Swarm network. As always, Swarm grows through its community. Whether you are running a node, providing feedback, or just curious about what we are building, your participation matters. Stay connected, stay tuned, keep the feedback coming, and let's keep building together. Thanks all for being here today. Back to you, Antonio.
Thank you, Nikki. Well, I heard that there are some other news regarding the NapNode package 2.5 that was also released. So for anyone who is using NapNode to spin nodes, that's very good news. And also, I would like to comment about the SWIP that Victor Tron has put out. That basically is about free uploads without requiring post-it stamps, and that enables low priority data like chat messages. So I just would like to bring those two things into stage so that if you're curious to it, just have a go for that. And without any more wait, I will like to invite to the stage Dan to comment about this little sneak peek that we will give you with this multi-chain app. All right. Hello. Dan, are you here? Hello.
Yeah.
Can hear your lovely voice.
Thanks, Antonio. Very much enjoying this.
If I can share my screen. 1, 2, 3. I'm gonna play a video, so and it's not stopping. So don't miss any part.
Okay. So
Goes.
I've been drafted in as B team to show off Cardinal Error's very nice DApp. Very nice looking and very nice working. So it's I think the first time I've seen Swarm directly connected to a wallet extension in the browser, and the key functionality here has been to enable cross-chain swaps that directly result in the purchase of a stamp that is also connected to our gateway and enables users that don't have a node of their own to use ours to upload data to the Swarm. So as this is the various kind of cross-chain steps working through. And then pretty soon the upload dialog will appear. And yeah, so this is a sneak peek. We're in the process of, as Nikki said, finalizing things. Probably not the last bugs, but we're kind of getting through the majority of them. And yeah, that's it. Upload successful. So that's the hash and then the file coming back out of the gateway. And then that, of course, will come out of other gateways and your own nodes if you're running them. And then we're looking, these are the start of some functionalities to manage the stamps and enable you to upload again to various, what they're called here, buckets, but also batches. And yeah, so that's basically it. Look out for beta testing opportunities in the Discord, which will be coming soon. And we'd love your help and feedback, any ideas that you've got. move that forward, or if you find anything that you struggle with, then get in touch, reach out. We'd be happy to hear from you. Coming soon.
All right. Thank you so much, Dan, for that voiceover over the video. It was great to hear your insights on the thing. So get ready, everybody, to mainnet release. The date is going to be announced pretty soon. You can follow up on Discord. Thank you, guys, and keep it around just in case something pops up in the chat or further on the main channels.
Thanks, Antonio.
All right. And for our next section, we are going to go in focus. We are going to focus Aaron because he has two things to talk to us today. Talk with which are Node Spinup and BJS. Hello, Aaron.
Hi, Antonio. Hi, everyone. So please bear with me a little while I share my screen. This should be it. Yeah, you should be seeing my browser with some Node Spinup ease of use text. Can somebody please confirm? And then I will proceed.
I can see it.
Cool. Okay, so first off, I would like to share some insight about a ongoing multi-team effort currently in Swarm Foundation, which is going under the code name Node Spinup ease of use. And the purpose of this is to make the Node Spinup part easier and faster, and to make using Swarm, using your bnode, also easier. So there are 5 milestones to this project, and I will go through these 5 that you can see here. The very first one is the quick start guide, which is related to the Node Spinup. And we have actually already delivered this. This is the quick start guide of the official Swarm documentation, and it gets you through the steps from getting a bnode, funding it, creating your first postage batch, uploading some data, and downloading some data. Now this quick start guide is very straight to the point, easy to follow, not too many commands are required to execute, so it's a very big improvement over the previous version. Huge kudos to Noah for delivering this. The next one is the postage syncing improvement. So the postage syncing is the process when you're after running your bnode for the very first time. There is about 30 minutes when it's syncing postage batches from the blockchain, and you cannot really use your bnode at all during that time period. That's one thing. It's long and slow. The other problem is that Swarm's very first postage batch block on the Gnosis chain was about 8 million blocks ago, and many of the current publicly available free JSON RPCs, they are no longer keeping those blocks, so you will have trouble syncing your bnode if you are using free JSON RPCs. This is why we always recommend to run your own Gnosis node so you don't run into this issue. In this item, what we are looking for is to replace this postage syncing with a much nicer approach, such as creating the snapshot of what your bnode should be syncing and putting it either on boot nodes, putting it in the binary, putting it on Swarm, or just eliminating the need of syncing postage batch information when you are running a light node. Since you probably don't care about data, you're not going to be storing chunks in light mode. There are multiple ideas. This is being researched right now. The next one, the warm-up improvement, is about the 5-minute period after you run your bnode. So this happens every time. Every time you launch your bnode, there is 5 minutes when it's waiting for connections, trying to fill up all the Kademlia bins, and it's waiting with the, I believe, with the push sync and pull sync to start them. So it's a fixed 5-minute delay in every case. And you can actually configure it yourself with the warm-up time in your configuration. You can bring it down to 1 minute, and it would still have enough time to warm up, and you can still use it. So there's obviously some room for improvement here. We can bring this warm-up time down much more, so you can start using your bnode much faster. Something that we have already done is that bnode exposes whether it's in the warm-up period or not. So we can use this field to add an indicator in the client tools, such as the dashboard or the CLI, that you are not supposed to use your bnode yet. It's still warming up. The fourth item, the DevX improvements. This is the documentation of BJS, for example, if you want to start developing the apps on Swarm. It also entails the Create Swarm app quick starter, so you can run npm init Swarm app, and then it creates the project for you, so you can just npm install, npm start with some basic example. And also some other things. Something that comes to my mind is improving feeds. There are some minor issues there which could be improved for a much better developer experience. And lastly, the node funding improvements that is also related to the node spin up. So when you launch your B node for the very first time, B is gonna keep printing a message, cannot continue until there is a sufficient X die on the address, and you need to take care of funding your B node before you can start using it. So now with the multi-chain app on the horizon, we could possibly use some modules from there which take care of the bridging or swapping to bring in some improvements to the node funding part to make it more convenient for end users. And something that I want to show you some data about the node spin up for the very first time. So I did a recording of myself doing the quick start guide of our official documentation, and I recorded which step took how long exactly. So getting requirements, the first one, that's doing an apt update upgrade and getting NVM, 1 minute. Installing B and installing Swarm CLI, that's like another 1 minute. And then comes the postage syncing. And I was actually pretty lucky with this 23 minutes. I've heard 30 minutes, 40 minutes for the very first time. And to create a stamp, it's almost 2 minutes. That's because you are waiting for blockchain events and confirmations for your postage batch purchase. That's why it's so long. But then uploading some data and downloading the very same data to confirm that you can fetch it from the Swarm network, that's half a minute. So what's the moral of the story here? Even though it took almost 30 minutes to start a node from scratch, by the way, this was on an Ubuntu VPS, absolutely from zero. That was my very first time SSHing to the server. So even though it almost took 30 minutes, the active time that I spent running commands was less than 5 minutes. So I'm pretty confident that this number can be maybe even reach below 4 minutes from hearing about Swarm for the first time, following the quick start guide, and then putting data on Swarm. Like under 5 minutes, that should be possible if you can figure something out for the postage syncing. So yeah, that's pretty good stuff. That's the end of the node spin up and ease of use segment. So now, unless there are any questions or other announcements, I will move on to the BJS sequel. And I think I'm good to go. All right. So at not the last SEC, it was in January. So January, I presented some upcoming changes about BJS. And this was the very last segment of my presentation there. I listed 5 points as well on what the next steps will be. And it took 27 RCs published on npm.js, but we finally have it. So this is how those 5 points are looking now. we released the new BJS version. It's under the major version 9, and we did actually do a lot of QA on this to make sure things are working. We redid the complete testing suite to make sure we are testing for actual use cases and making sure that they work. We were using real B nodes for those tests to keep it as close to production as possible, and it's looking good so far. We are still working on the docs website for BJS, but the first preview version is already there. Probably by the next SEC, we will have a mature documentation website for BJS ready. The Create Swarm app, which you can use by running npm init swarm app, has also been updated to use BJS 9, and it's out. We don't have this item yet, which is about creating more projects for ideas on what you can do for Swarm, but this is on the way. And actually, some of these might also get inside the Create Swarm app. So when you are creating a default application from template, you can enable features for some use cases that you want to use Swarm for. And with the release of BJS version 9, we could unblock some issues in Swarm CLI and dashboard. They have also received the new version of BJS. For example, in Swarm CLI, now you can remove mentor forks without removing the children under the same prefix, just for one example. I will give you a recap. I will try to be as quick as possible on what the major changes in BJS version 9 are. And the first one is when you are working with tokens, there's two new classes, the BZZ and the die. You can construct them in a friendly way. You can give them a decimal string or plur, or for the XDie, you can use way, and then have convenient methods on them to print them in different format, but also to do some calculations with them or exchanging die to BZZ or the other way. Next one is working with the elliptic curve and keys, of course. So the new classes here are the private key, public key, ETH address, and the signature. So you can conveniently create a private key, for example, have a message, sign that private key, you get a signature with that. You can recover the public key from a signature, given that you know the original message. And of course, you can get the address of that public key. You can also, starting from the private key, also known as the signer, you can get the public key. From the public key, you can get the address, and you can also print or get different formats of these classes, like the compressed format of the public key or the checksum format of the address. I've also introduced some swarm types. The most common one is the reference. You can pass it a CID or a swarm hash and then have some convenient methods on them, like converting it to hex, converting it to a CID, getting the raw byte array presentation. And of course, this reference, along with hex strings and bytes, are accepted in pretty much every BJS method where it makes sense. There are some other new classes, like the topic for feeds, the identifier for SOCs, the feed indices for also feeds, and they also have some methods for better developer experience. And there are even more, like the batch ID, span, peer address. When you are working with BJS types or BJS methods and you see the return type, you will very often get these back, so you know exactly what they are, what they do, what functions they have, and so on. We also have client-side chunking now in BJS version 9. It's available on the Merkle tree class. So how it works is that first you create a function, what should happen when a chunk is ready. Nearly in every case, you want to upload that. So you call the upload chunk with a batch ID and the chunk. And with this Merkle tree, you can keep streaming data to it. So for example, if you have a read stream, or if you are in a browser and you have a file reader, you can keep appending data to the tree. It will trigger your onChunk function many times. And when you are done with the data, you can call the tree finalize method to finish it up and receive the root chunk that you can then use or share with others. We also have the client-side stamping or the stamper. This example is very similar to the one before with the client-side chunking, except we have a stamper here. So it needs three things. It needs a private key, the private key which was used to buy the postage batch. It needs that postage batch, of course, and it needs to know the depth of that stamp. And the way you use it is very simple. When you have a chunk, you want to call stamper.stamp on it, and it will automatically create the envelope, which is used to upload the chunk. And in that case, if other B nodes have this enabled or with gateways, you don't need to use your own B node anymore to upload. You can use any gateways or other B nodes on the network who have this enabled, and they will relay the chunks on behalf of you because they no longer need to stamp it. You have already done that on the client side. So this enables a lot more use cases, and it's pretty cool. After you are done using your stamper for one upload, you can call the getState method on it to get back all the 65,000 buckets that your stamp has, and you very likely want and need to persist it somewhere. So when you are using the very same stamp for the next time, you can create your stamper by calling the stamper from state and pass this state. So you retain the previous bucket information, like which bucket has been filled up, how much. You want to know that on your next go. Otherwise, you would be overwriting your previous chunks, which you very likely don't want, but there might be a use case for that too. Okay, some more new stuff about postage batches. There are new methods for working with postage stamps. Now you can, maybe I will start with this bottom section. So now you can create a postage stamp without having to know about what they are. You can use the new buy storage function, and you don't need to care about amount and depth. You can just specify a size and a duration. So you can use size from gigabytes and duration from days or weeks or year. There are many methods on these classes, and it will figure out what depth to use and what amount to use, and will just simply give back the batch ID. And very similarly to this, you can also extend the storage duration and the size. These are the previous top up and dilute operations. And here you can also use the duration and size classes to tell your B node what you want. You don't need to care about amount and depth. And for each of these methods, these three, you have a corresponding function to get the cost, which is going to tell you, for example, if you want to create a batch for 4 gigabytes and for 1 day, it will tell you how much BZZ that is. And there are also some new properties on postage batches. For example, when you call the b.get all postage batch function, so there are new properties on the returned postage stamps. Those are duration, usage text, size, and remaining size. They should be self-explanatory. So that's that. In the new BJS version, we have a new manifest API, also known as the mentor nodes. They are key value collections that you can use to create websites or file structures. And to use them is simply just invoking a new mentor node and adding forks to them, and then saving that to the Swarm network. You get back the root hash. To load an existing manifest from the Swarm network, you can use the mentor node.unmarshal method and then call load recursively to get all the children, all the forks as well of the node. And it has a lot of functions that you can use, for example, the collect and map, which gives you the whole structure of the manifest. You can also change existing data within the manifest. This is the scenario that I described earlier. You can add two forks, foo and foo bar, remove foo, and foo bar is retained. So I'm just saying this example because previously it did not work if you were trying to use it with mentor.js. So now this is part of BJS and has been fixed. GSOC also made its way into the BJS version 9 to mine the signer for the SOC that you will be using for messaging. It's a very simple one-liner function call. Overlay is the overlay address of the node who you will be messaging and who will be listening. And identifier is something that you two agree on to be the identifier of this exchange. To send a message, again, just a one-liner, you need a batch ID because, of course, you are writing the signer that you mined here and the identifier and your message, which can be UTF-8 string or arbitrary binary data. And on the service node side, who is listening for GSOC messages, there is the b.gsoc subscribe method that you can call. This is again the same signer that we mined, the same identifier, and just very simply two function callbacks, what should happen on message and what should happen on an error. So you can use the GSOC feature with these three methods. So I talked about create swarm app, and this is what it looks like. So I first ran the npm init swarm app command. It prompted me to install, and then it gave me the help or the usage guide. So you just need to type npm init swarm app and then give a name to your project and a type for your project. So for example, my app and Node.ts. The possible types are Node if you want CommonJS, Node ESM if you don't want TypeScript but want modules, Node.ts if you want to work on backend or CLI projects and you want TypeScript, and the only currently available front-end scaffolding is Vite with TSX. And for example, here I ran npm init swarm app. I gave my project the name message board and chose the type Vite TSX. And it simply creates a folder and tells you to go to that folder, do an npm install, and you can run npm start to get like a basic project, basic application that does some things like creating a postage stamp, uploading data, and fetching data. And then you can start building your application from that checkpoint. You don't need to set this up yourself from zero. And I just want to quickly mention Swarm CLI, that it has been also released with a new BJS under the hood, and also one new command, the CID command, to convert any reference or CID either back to a Swarm hash or to a CID. And that's actually the end of my list. So thank you, everybody. So BJS is released under npm.js, ethersphere/BJS, and you can also find it on GitHub. It is, of course, fully open source. And that's all. Thank you very much.
Thank you so much, Aaron. That's been amazing. Lots of stuff. If you want to give any questions to Aaron or it appears to you along the way, please use the state chat or the other channels. Thanks so much for that, Aaron. Really insightful. All right, moving on to our next section, which is community talk. And we have two community talks today. The first one, it's called OCE Registry Implementation on Swarm. What is this? Well, in December 2024, one team built a way to store Docker container images using Swarm instead of traditional cloud storage, connecting Swarm to the standard Docker registry system. They also looked into how to handle things like permissions, payments, and human-readable names, using ENS and on-chain payments to make it easier. I would like to invite to stage Andrew and Aata from dboot/uncloud team to present a proof of concept for a working container registry on Swarm. Hello, Andrew.
Hi, thanks for having me. Can everybody hear me okay?
Yeah, loud and clear.
Okay, great. Well, yeah, before I get started on the demo, I'll say a little bit about the why and the what of what we did. First of all, why containers? Well, containers are basically how most web services are deployed. So that's a huge amount of software being deployed by via Docker and similar OCI spec tools. And hence, that's like potentially a really big addressable market for Swarm storage if we can connect the two together. Basically, anything that has to do with containers can reach millions of DevOps professionals around the world. Just to give a couple of numbers, I just looked up what Docker quotes its usage rate as. Docker claims that to have 17 million registered developers as of 2024 and 25 billion pulls per month from Docker Hub. So let's get all of that activity on Swarm. Secondly, distributing software is potentially an interesting niche for Swarm storage. Basically, considering the price point of Swarm, it's fairly expensive. It's priced near towards the upper tiers of some of the managed centralized cloud services. On the other hand, it's far cheaper than other decentralized storage systems that offer permanent storage like Arweave and Ethereum State. So while it's not, while it's probably too competitive for storing petabytes of climate data or archival or backup data, it's quite believable that somebody might pay $50 a month to use Swarm to distribute a few hundred gigabytes of software. Okay, now what? I'm going to try to share my screen now. And okay. Right. So containers are distributed by something called a container registry. Container registries have an open specification called the OCI distribution spec. So you can see, provided my screen is actually appearing. Yeah. You can see here the Open Container Initiative, which is started by Docker.
One second. Sorry, Andrew. Yeah, there are some people who cannot see. I cannot see it. For instance, I have this yellow exclamation mark. So for anyone who cannot see it, we enable the link because this thing is recurrent. Discord manages to play with us very often. So we have created this link up on the stage chat where you can click and see Andrew's presentation, just in case you can't. That was it.
Okay. Do I need to do anything different or should I just continue?
No, just carry on, please.
Okay. Yes. Well, for everybody who can see, you can see that I'm just showing some GitHub repos at the moment. This is the distribution specification. It basically specifies an API for pushing and pulling containers. So all you have to do to plug, say, Swarm into a container registry is to implement this API, do whatever you like on the back end, and then ordinary container tools like Docker or Podman can just interact with it without modification. So this is going to be something that works with a modified registry, but just completely vanilla tools, like in the demo I'll use Podman. And as you can see, there's basically a list of 13 or so endpoints for blobs, manifests, and tags. I won't go into the details of that, but if you're into nerdy stuff, it's kind of interesting to read through that spec. Now,
can I ask real quickly, is anyone seeing the screen?
I'm popping in. So apparently, yeah, there are people who can see it, but I can't. So I would share, but I can't share because I don't see myself.
Okay.
So
yes, unfortunately, I can't see it either. Okay.
Oh, Dan sees it. Oh, okay. Heterotic sees it. Can somebody just go to this screen and share it for everybody else? Like go to the link I pasted in
okay.
YouTube, and then share screen
also,
and come back with. Oh, yeah, excellent. Or just head to Twitter, I mean X, because we're also broadcasting there. Okay. Sorry for this interruption.
Okay. Yeah. So that's the OCI spec. What's more, as well as the specification to work with, there are multiple open source implementations of this specification. So we don't have to start from scratch with this API. You can go and try to modify or fork something that already exists. And what we've done is we've gone into the reference implementation of the distribution spec, which is called distribution/distribution on GitHub. Basically the reference implementation of a Docker registry. And this thing, it's written in Golang, and it has a pluggable system of storage drivers, which I'll quickly show you. So basically this allows you to configure your storage backend from local storage or multiple different cloud providers. So you can see we've got, this is the vanilla implementation. There's like an Azure provider, Google Cloud, AWS, and in-memory and a file system one. So what we've done is we've gone and implemented our own driver for this distribution, implementation of the distribution spec, which connects to Swarm. And what it does is you're going to run a copy of the registry locally configured to use this Swarm stuff, and then your Docker is going to connect to, which I'll demo in a second, your Docker is going to connect to this local adapter. That's going to pass the request onto a B node also running locally, and then that's going to spray your containers into Swarm or fetch them back from Swarm. And now, if I can figure out how to change the stream, I will show you the actual demo. Where is? Okay. Yep. So what we're seeing here, if you can actually see anything, is I've got 3 shells into this Hetzner node where I've got a B node running with the logs displayed in the top left. I haven't set the log level high enough, so those logs are not going to be very interesting to look at. And now I'm going to fire up this registry and then do a few commands using Podman to show how it works. But maybe first thing I'll do is show you what the configuration looks like. So you can see around line 12 here, there's the Swarm. Line 7 is the storage configuration, and within there we've got Swarm, and then there's a few things listed in there. This private key is, obviously you shouldn't normally share that on a live stream, but this is just a demo. All you can do if you write down this private key is publish to the same registry that we put up for this demo, which is I'm not that worried about. This is where it's going to find the B node, and this is a postage stamp batch to use for paying for the uploads. Now let's fire it up. So this is the registry blasting out logs in the bottom left now, and what it's doing is it's mapping out a bunch of paths. I don't know if anybody can see the actual messages. These are from the sort of internal path layout of the way that the reference implementation implements its storage, right? So it takes your containers and distributes it up to these paths. They're all mutable, treated as mutable paths, and they're implemented with a Swarm feed. Now, if we go back to the big screen on the right, let's have a look at our images. So this is a list of the locally stored container images on the system. The names have a prefix which basically tells the client which registry it thinks that the container comes from. So what I'm going to do is I'm going to pull to demo it, I'm going to pull a container from a standard repo. I've chosen to use the Alpine one because it's a nice compact size. And I'm going to re-tag it so that, as to tell my Podman that I'm now going to connect that container image to the local registry. which is running on port 15,000. That's here. So I need to do a podman tag, docker.io/library/alpine to localhost 15,000/demo. And now is the moment of truth. I'm going to push this thing and hopefully it should do something. So on the left, you can see things going wild. It's creating new metadata and blobs. It's got a readout, that's Podman client, showing me the progress meter. Unfortunately, the Swarm, like the reporting of progress from the Swarm uploads, is not compatible with Podman's understanding. So the progress meters that Podman displays are pretty useless. It says it's done now, but it isn't done. It needs to finish updating a bunch of feeds and copy a config file. But hopefully shouldn't take too ridiculously long. If it does take a long time, now would maybe be a good time to shoot in some questions. Maybe I'll fill in the gap a bit. Basically, all of the implementation here was managed by Alok, who couldn't be here today, unfortunately. Like we did some initial strategy about the design and put together the grant application, but Alok and his cousin basically did all the implementation. So big shout out to him. It was based a lot on the ideas used for the file system he developed a few years ago. Also based on Swarm.
So yeah, I just had, first of all, this is great. I'm really impressed. I was wondering, with Docker, then they have the different sort of layers of the container to reduce the amount of data that needs to be transferred. Is that integrated here, or?
Yeah, that is a great question. Actually, when we started out, I was imagining that we would try to come up with some way to like make the deduplication of Docker layers talk to somehow linked to the immutability of Swarm storage. As it happens, like the deduplication is implemented, but it's not implemented in a way that's somehow Swarm aware or anything like that. The reference implementation just splits these things up into blobs, which are content addressed, and then it maps to them to these paths. But we haven't done anything like special to respect the fact that, for example, some of these paths are known to be immutable because they're content addressed. So yeah, that is something that I'd like to explore, because obviously it's kind of a waste of resources to store these immutable blobs under mutable paths.
Great, thanks.
We've actually finished. Okay, so that has uploaded. Now, in order to demo this, what I should do is I should delete this images from my local machine, which I will do now. And I should also delete the original copy, because, as was just mentioned, Docker stores the deduplicates the blobs for this these containers. So if I've got two containers which have the same data but different name, trying to pull, when it tries to pull the one that I've just removed, if there's another copy of it under a different name, it's just going to figure out that that's the same content and just work immediately. So it won't really be testing any downloads there. Although we will still be testing pulling the manifest from Swarm if we were to try to pull now. Maybe I could just demo that actually. Might be informative. Yeah, so that was very quick. Another reason that was very quick, which I forgot to mention, is that the registry itself implements an in-memory cache. So actually, we didn't go out to Swarm to do that. We just went to the registry in memory. So we needed to pull that down and bring it up again to really show what's going on here. So let's delete that again. Let's give the registry a little bit of time to find all its paths again. Maybe another comment while we're waiting for this to happen on performance. Obviously, this is kind of slow compared to what you might hope for a container registry. Maybe you don't have an opinion about how long it should take to start up a container registry, because most people are using remote container registries. But at least to upload and download, you know, one would hope things are going to be pretty fast. One of the reasons we think that this might be happening is because the default storage layout for this reference implementation of the OCI spec uses a lot of mutable paths, and these are implemented with swarm feeds. Currently, the performance of using loads and loads of swarm feeds is not that good. Outlook has an idea of how we can implement it using just one top-level swarm feed to point to the latest version of the registry, and everything else is immutable, and that might give significant performance improvements, but we haven't implemented that yet. Okay. And now the moment of truth, let's pull this. Yeah, that's a success message, says it's time to try it again. Okay, so now there's a bit of a pause because it's going to have to go out to Swarm. But it shouldn't have to go out to Swarm for the full blob. It's only going to go to Swarm to get this manifest, which tells you what the content blob is. And yep, there it is. It's pulled it. And maybe we can do a proper full demo where it pulls the blob as well. And you may have to cut me off if this takes too long and you need to get on to the next item. But let's give it a try. Okay, Podman images, we're looking for this ADED image, just making sure we've got rid of it. It's not there. Okay, let's pull it. And it's having to copy the blob. It's really going out to Swarm for this. You can tell by the fact that it's zero, still on 0 bytes, because it can't report the download progress properly. Yeah, this will be the last thing that part of the demonstration. So also, again, if there are any sort of final questions, you might as well pose them while it's downloading this thing. Yep, success. Okay, that's the end of the demo.
All right. Thank you so much, Andrew and Ata. I don't know if we have any more questions here in this stage chat. Let me have a quick look. No, I don't see any. All right. So thank you for this. It's impressive work. Thanks for that. And now let's please stay with us just in case something pops up. And let's move on with our next community talk, which is talking about provenance, swarm-based data provenance framework. Provenance, that, by the way, it's a great name for a Marvel superhero, is the documented history of a dataset's origin and transformations, and is increasingly important for regulatory compliance, ethical AI, and data accountability. I would like to invite to stage Chert, who will follow up from last month's presentation with an update on the informational SWIP on data provenance. Hello, Chert.
Hi, Antonio. Can you hear me?
Yeah, loud and clear.
Oh, okay, great. So, hello. Thank you for having me here today, and everyone in the audience listening in. So, we're continuing with updates about data provenance on Swarm. Antonio has already reminded you what data provenance is about. Under the fellowship awarded to Data Fund by Swarm for data and model provenance for decentralized AI, we're proceeding with the steps towards building a toolkit to allow for Swarm to be used as a data provenance storage solution. Today, I will present a SWIP proposal for data provenance framework on Swarm. You can find the proposal as a PR in the SWIP repo, PR 71. The SWIP describes what features the toolkit would have and how provenance data would be stored on Swarm. So let's touch upon the key features of the proposed framework. Decentralized storage. The framework will provide a decentralized storage layer for provenance metadata and data, ensuring immutability. This will mean that once data is stored, it cannot be altered or deleted, providing a reliable record of data origins and transformations. The framework will be designed to accommodate various provenance standards without enforcing a specific format, which will allow flexibility for users to choose the standard that best fits their needs, ensuring compatibility with different systems and applications. It will use JSON for metadata, which will include essential fields in addition to help manage the data, specifically in regard to Swarm storage. And it will have support for tracking of time to live for stamps and top-up mechanisms, which will allow users to manage the availability of their data on Swarm more efficiently, ensuring that it remains accessible and when as needed, and controlling the storage costs. And this should bring forth benefits for developers and users in the ease of use, which is the most important factor for easy adoption by both Swarm developers and non-Swarm savvy users, and should help bridge the gap between decentralized technologies and mainstream users. It should open Swarm to Web2 communities, providing a seamless way to leverage Swarm decentralized and immutable storage for provenance data, and could attract new users and applications that require secure and transparent data management. And finally, regulatory compliance. It has the potential to help users comply with emerging regulations like the EU AI Act, which require transparent data provenance. The framework is currently in the design phase, with the SWIP serving as the foundation for its development. So you're invited to review it and provide feedback. This is crucial for refining the framework design and ensuring it meets the needs of developers and users. So thank you for having me, and back to you, Antonio.
Thank you, Chert, for this comprehensive follow-up. Thank you. All right. Any questions, of course, in the chat stage. And now let's move on to the AMA questions and community. Anything you would like to say? It's your moment to voice it out in the chat or in the chat box, or you can also come here to stage if you want to voice it over. I have a couple of them that I will read out and try to comment on them because they are addressed to particular things. For instance, the first one, it's why BCC was delisted from OKX. They are asking if there's any changes in fundamentals, and because the market has been hit hard. Another question in a similar line: any plan to improve the liquidity of BCC and decrease the bad effects caused by the delisting? When will the multi-chain function be released? This one was addressed earlier, but well, we have a couple of them about the getting delisted and the strategies. I would like to comment or to address them together, but essentially there's no change in fundamentals if that's your worry. Swarm has the same vision and keeps building keeps walking the same path since its inception, but the market is as it is, and the centralized exchanges have certain requirements, particularly these days, in terms of regulatory concerns. And well, they have regulatory concerns and they have regulatory pressure. So